But yeah, so the next session is our community announcement. So this is going to be sort of lightning talks from different members of the community. I'm going to, because their talks are short, I was going to do the slides, and then if speakers can just let me know when they're ready to advance. And I'm also going to, I think I've gotten the links and contact information for everybody, and so I'll try to post those into chat, just so you can see them kind of as they come by. I will also, once we're done, I'll ask that these slides be added to the webpage so you can come look at them later. I mean, again, these are the quick commercials. Hopefully they, some of the things are things you want to follow up with. So, do that kind of after. Okay, why don't we get started?
Oh, all right. Hello, everyone. I'm Tia Newhall, and along with my co-authors, Suzanne Matthews from West Point and Kevin Webb, who's at Swarthmore with me, we are seeking community support and involvement in the next phase of our free online textbook that introduces computer systems called Dive into Systems. If you're not familiar with our textbook, I'll just give you a quick high-level overview. It introduces a broad set of computer systems and computer organization topics, and of particular interest to this group, it also introduces parallel computing. So we focus primarily on multi-core and shared memory parallelism in depth, introducing p-threads programming and also a little OpenMP. But then we have some other coverage that's looking forward to other types of parallelism. We've been focusing the past 2 years on writing content and editing content. We're finishing that up over the summer. And we've had a lot of community support with that, with both early adopters who've used our book and given us feedback, and also external experts who've served as chapter editors. And that's been extremely helpful to improving the content of our book. That was very hard to say. Next slide, please. So what the next phase is developing exercises and instructor resources for our book. Again, we've been really focused on editing. We don't have a lot of this content, and we're hoping to get some community support to help us create chapter exercises. In particular, because this is an online textbook, we want to develop a lot of interactive examples and exercises, things that students can use to try out, maybe modify, test things along the way, and also just some end of the chapter exercises and instructor resources as well. What we're looking for is people who might be interested in working on different topics. I've listed the 15 chapters in different topics off to the side in that figure. We plan to create sort of pods of community members working together on a set of exercises for related content. We're currently working on an NSF grant proposal that, if funded, we would have some support to provide stipends for participants, and also some travel support for SIGSI, where we plan to have annual meetings of pod members and people interested in contributing. So with that said, you can go to the next slide, please, David. If you're interested in learning more about this, we have a very low volume mailing list. You can subscribe to diveintosystems.org, and we will post more updates as we have them about this project. Or feel free to also email any or all of the authors, and I've included our emails there. So thank you.
Okay, I guess I'm up next. So I'm Suzanne Matthews. In addition to participating in Dive into Systems, I am one of the PIs of the CS in Parallel project. So for those of you who aren't familiar with CS in Parallel, it was started by two of my colleagues, Dr. Libby Shoup and Dr. Dick Brown from St. Olaf back in 2010, and Dr. Joel C. Adams, who will be presenting our paper later this afternoon, is another one of the PIs, and I've been involved with the project for approximately 6 years now. So our goal as CS in Parallel is to produce high quality free materials to the community. And into that end, I want to share with you some of the innovations that we have recently developed and are coming on the docket. So next slide, please. So PDC Unplugged is a project that I started. So for many of you might be familiar with the notion of an unplugged activity. The goal is that by teaching concepts without computers, we can usually help students who are beginners learn using their other senses how certain algorithms or certain pieces of hardware could work. So PDC Unplugged is actually a repository of unplugged activities that I collected over the last 30 years of PDC literature. It is particularly useful for instructors and faculty since we map the activities to not only the CS 2013 PD learning outcomes, but also to the various parallel topic areas in the TCPP report in 2012. You could also filter activities by suggested courses, mediums, and senses. So how can you help us improve this project? Well, if you have any awesome unplugged activities, please consider contributing them to PDC Unplugged. So it's really easy. The repository is free to all on GitHub, so just submit a pull request. Activities are created in Markdown. And if you have any other ideas on how to contribute or suggestions for improving the project, please contact me directly. Next slide, please. Okay, so some ongoing CS in Parallel efforts. So I'm really excited to announce to you today PDC for Beginners. So my colleagues at CS in Parallel and I, we have an alpha release of this new textbook. It's an interactive online textbook for targeted toward beginning CS students, primarily those in CS1, CS2, and your basic data structures and algorithms class. Unlike a regular textbook that is meant to be used in full, our textbook is meant to be in piecemeal. We really expect people to maybe use a section or a chapter at most in various different courses, and in that way inject a little bit of parallelism in various parts of the CS curriculum. So this is an ongoing project. We have a number of contributing authors who have signed on, so we're really excited. So if you would like to take a look and give us feedback, we would really appreciate it. And last but not least, we are going to have another virtual 2021 workshop this summer. It is going to be from June 21st to the 23rd. It is a follow-on to our very successful 2020 virtual workshop, which you will hear about later this afternoon during Joel's presentation. And one of the differences this year is that we're going to have hands-on experiences with Raspberry Pi clusters, which we are planning to ship to you for free, along with remote systems. So if you know people who are new to PDC and they want to learn strategies for hands-on teaching, especially in remote environments, this is a great workshop to attend. So I've included the link to the workshop right there. And with that, I am done. So thank you.
Hi, everybody. I hope you can hear me. My name is Kate Cahill, and I am Education and Training Specialist at the Ohio Supercomputer Center. And I'm also part of the Exceed Workforce Development Group, focusing mainly on education programs. And today I just wanted to highlight several of our faculty-focused workshops that we're offering this spring. Next slide, please. So these are two different areas that we're doing these summer virtual workshops. Both of them are accessible through the Exceed portal. So if you go to the Exceed portal under training, you can choose course calendar or just use that link at the bottom of the slide. And that's how you can register for either of these events or any other Exceed training events. And so the events that I'm highlighting here, the first one is Introduction to Computational Thinking Across the Curriculum. And this is actually 4 different events These are taught by Bob Panoff from Shodor. So these are our computational thinking workshops that have been offered through Exceed over the years. We're doing an overview webinar next week on May 27th, and this will kind of give you a sense of what is going into the hands-on workshops. And those are a series of 2-day workshops throughout June that focus on different areas and different tools you can use for doing hands-on activities and with computational thinking type tools and modules. And you can see the 2-day workshops. The first one focuses on modeling with spreadsheets and web resources. The second workshop is systems modeling, and the third is agent-based modeling. And those are all separate. They're not a required series. You can sign up for any or all of them. And the second workshop that we're doing is Advanced Computing for Social Change Curriculum Development Workshop. And this is a faculty-focused workshop to share curriculum materials and discuss how to infuse advanced computing for social change topics into curriculum with all different types of courses. So this is domain agnostic. And this is based on our student program. We have this workshop called Advanced Computing for Social Change. You also, if you are aware of the student program as part of Supercomputing, might know this as Compute for Change. They're the same workshop with different names. And this is a student event where the students can work with some big questions of social importance and the data that they can find to answer some questions about those ideas and share their analysis of data and how using these tools can help them think about these problems. And so this workshop is to bring that into more courses. And that workshop is 2 days in June, June 17th and 18th. And as I said, both of these workshops, you can register on the Exceed portal and check out the portal for other training events this summer as well. And thank you very much. That's it from me.
Hello, everybody. I am Alexandros Iliopoulos, and I'd like to talk about the recent release of OpenSilk version 1.0. Next slide, please. So OpenSilk 1.0 was released a couple of months ago, and it is a new open source implementation of the Silk parallel platform. You can find pre-built binaries, source code, and built-in usage instructions online through the OpenSilk infrastructure GitHub repo. For those of you unfamiliar with it, Silk and OpenSilk extends modern C and C++ with 3 keywords to expose logical parallelism, which are a Silk spawn, which indicates that a computation may spawn off in parallel, Silk sync, which synchronizes all spawn computations, and a Silk for, which indicates that all iterations of a for loop may happen concurrently. The OpenSilk runtime schedules and load balances the computation using a work stealing mechanism, which is provably efficient and automatic. Other advanced features included in OpenSilk include the Silk reducer hyperobjects, which can be used for efficient and trace-free parallel reduction computations. And finally, OpenSilk 1.0 includes 2 software productivity tools, to wit the Silk Sun race detector for finding determinacy races and debugging Silk programs, and the Silk scale scalability analyzer for measuring parallel performance and scalability. The plot on the bottom right, for example, was obtained using a Silk scale benchmarking and visualization script for a parallel quicksort over 10 million integers and varying numbers of parallel cores. Next slide, please. OpenSilk has been developed for Linux and Unix-like systems on Intel x86 CPUs and has been tested on a variety of operating systems. We also currently have experimental support for ARM CPUs, including the M1 CPU found in new Apple computers. And we also make available a Docker image of Ubuntu 18.04 with OpenSilk 1.0 installed. We are currently actively engaged in developing documentation, tutorials, and a variety of teaching materials which we hope to make publicly available in the very near future. Some of that is informed by our recent experience in using a beta version of OpenSilk to teach a course on performance engineering to a class with hundreds of MIT undergraduates in the fall 2020 semester. There is a lot of other ongoing work on OpenSilk in the compiler, the runtime, and various linguistic features. But amongst other things, we are also working on developing and curating a collection of Silk libraries. And in fact, we will plan to make certain development projects available for community engagement in the near future. A port of the RR debugger integrated with Silksand for easily finding and debugging determinacy races, and integration of the OpenSilk compiler and runtime with the Julia language and the PyTorch framework. So that's more or less what I want to talk about. Please do not hesitate to get in touch with us with any comments or feedback that you might have, or even requests for features or teaching materials or any other idea that you might want to discuss. You can find us through opensilk@mit.edu, and you can find all currently available materials through the OpenSilk GitHub organization. Thank you.
Okay, so I'm actually going to talk next. So this is going to be the talk where the slides advance the smoothest, but the text may be delayed. But yeah, so I'm talking about our project Touch, which I'm working on with Phil and Apan here. So our sort of focus is on heterogeneous parallel computing. I should have put parallel in there. But our idea here is that most computing is not done by uniform systems anymore, right? So this at the very high end is this figure on the left showing the percentage of the top 500 systems that have some kind of acceleration, often at this point graphics cards. And so the chart keeps going up and up. It's also heterogeneity is also very common on the low end, right? So with a single node or with low power systems, right? Again, power is the main issue here, right? So my phone has fat cores and thin cores, right? More or less capable cores. You can have, even on a uniform system, you can use DVFS to sort of over time, you'll have differences in terms of how powerful the cores are. The bottom right there is sort of an emerging, right? If we start thinking about, large cloud-based systems with edge nodes and lots of sensors on the bottom, again, it's a very heterogeneous environment with lots of different kinds of computing. And so our sort of general sense is that, this is definitely something that's happening and that's coming, but you wouldn't necessarily know it from our curricula. In some ways, this is like the parallel computing was 15 years ago, right? It's a topic that's coming. It's taught in some upper level advanced courses. Some places maybe do more, but it's not sort of throughout. And so our project is basically trying to do that. So we've created modules that would be appropriate to putting it into different parts of the curriculum, right? You can do it in low level courses. Upon presented, I believe it's 2 years ago, on some modules that he did that were going to CS2 or potentially even CS1 that are just teaching some very basic ideas. You can do algorithms, you can do programming courses, you can do systems courses, you can do hardware courses. Lots of different ideas about where you could put this kind of thing, just so that students see it and know that it's around. Okay, so here's actually all my other links here. But if you're interested, right, again, this was my commercial, you can go to our project website. We have the modules available in the GitHub repo. We're also going to do a workshop this summer. We're going to do it over two distinct days, right? It's a virtual workshop. And so there's a week in the middle, and the idea is that we'll meet with you individually or in small groups to help you customize the modules or do other work that's sort of required in order to get it into your class. With the idea that we don't normally pick things up that other people have created and use them unchanged, right? There's often some kind of a conversion process, and so we're trying to build that in. And so this is a module or a workshop that we think is actually appropriate for people in this community, included because, again, even if you're doing homogeneous parallel computing, right, they're still adding the heterogeneity aspect to it as well. So, and yeah, so be in contact. Thank you. Oops.
Hello, I'm Eric, and I wanted to talk a little bit today about CS materials. And to give a little bit of context, it's a tool that comes from the fact that adopting PDC is hard for non-PDC experts. And essentially, very often what we tend to do is that as a community, what we output are essentially curriculum guideline, thing that looks like what ACM and IEEE are producing, or the PDC guideline that CEDAR has generated. But to take the words of Karen, what adopter wants, they want puppies, because puppies are fun and you want to play with them, and that's what you want. And in this context, what those puppies are, they're essentially all the materials that you may need in order to adopt PDC in your courses. There are things like textbooks, there are things like activities, assignment, lectures, and we've heard over the last 30 minutes or so of a lot of the things that are being developed. But the main question that people that may want to adopt those materials have is what it is that I should be using in my particular class. And in order to help people figure out what they should be using, we have developed a system called CS Materials. And David, if you may move forward. Essentially, what CS Material is, it's a system that enables you to contribute your materials into the system, and that provides all kinds of tools around that enable people to search for materials, but also to analyze what their courses look like. And I won't bore you with the details, but what I'm trying to tell you is that you can help PDC adoption across the country and hopefully the world by using CS Material and contributing your class or your material inside the system. Obviously, we're interested in materials and in classes that are linked to parallel computing. So if you are teaching a parallel computing class, we're interested in having you enter that class into the system. If you have developed a class that actually integrate parallel distributed computing into your CS1, your CS2, your algorithm course, we'll be glad to have it as well. But we are also interested in having you enter regular intro CS courses that do not have parallel distributed computing. So even if you have, even if you're teaching, say, data structures that does not have PDC inside, we are interested in hearing how you teach PDC. And the overall strategy that we're trying to do is to figure out what are the materials out there and how do they map to the contents that we're trying to teach. And on the other end, we're trying to figure out how are people actually teaching those courses in practice, and then our system will help us do the matchup so that people that want to inject some parallel and distributed computing content inside of their classes will be able to have ideas of how they can do that. And so that's what our system CS Materials do. And I hope that you will be in touch with us in order to contribute your class in the system. And we do have, it's a little bit of work, but it's not too much work. And hopefully we have summer coming. So I expect that some of you at least will have some time to spare. So we have stipends that are coming from an NSF grant in order to help you make the decision to hopefully integrate your class into CS Materials. And please be in touch with us. We'll work with anybody that wants. Thanks, David.
Okay, that was actually the last one. Let Eric have the last word there. So now it is time for a break. I thank everybody who made an announcement, and I hope the rest of you will take advantage of those, find out about some things to get involved with. So like I said, I will post the slides on the workshop webpage if you want to follow up with any of the speakers.